Current Transformers CT.
Assalamualaikum and hi everyone. My name is Sofia binti Abdul Hamid with matric number 153214. I am a second year student from Science of Education from School of Educational Studies, and I am the presenter of this group.
Hi, Assalamualaikum. My name is Puteri Norsyazana binti Abdullah Sani, second year from PPIP, School of Educational Studies, USM. I'm taking course Science Education, major Mathematics, minor Physics. I am the scriptwriter for Group 4.
Assalamualaikum and hi everyone. My name is Nassmyn bin Redzuan. I am from School of Education. I am majoring in Mathematics and minoring in Physics. So I'm a second year student and I am an editor.
Our topic for today is about current transformer. So let's get started. Have you ever heard about current transformer? No, not that transformer. Do you know where we can find current transformer? Current transformer can be found mainly at electric substations and also can be found at utility metering, or known as electric meters for households billing purposes. Yes, now you know where to find it. But do you know its functions? No? Okay, let me tell you. Current transformer, or also known as CT, is a type of instrument transformer that is a current measuring device used to safely reproduce a low-level current that will represent a higher current level for the purpose of metering or protection. CT has a primary winding and a secondary winding, which will determine the alternative current generated in its secondary, which is proportional to its primary from the difference in ratio. In simpler words, CT is used to lower down the current to make it measurable by the ammeter. Wow, interesting, right? Now let's dive into its concept. The concept behind CT is similar to power transformer, as when the alternative current flows through the primary winding, alternating magnetic flux is produced and induced alternative current in secondary winding. CT operates under short circuit condition but not open circuit, as the load impedance is very small, as current transformer does not rely on load impedance but depends on the current flowing through primary winding. There are several types of CT that can be classified according to its function construction, which are bar CT, wound CT, and window CT. Also, CT can be in the form of solid core CT, split core CT, and clamp-on style CT. And there are two main applications of CT that can be classified as measuring current transformer and protective current transformer. Okay guys, have you ever wondered how CT works? The primary windings of the CT carry the current which is to be measured, and it is connected to the main circuit, while the secondary windings of the transformer carry the primary current proportional to the secondary current to be measured, and it is connected to the current windings of the meters or the instruments. Whenever an alternating current flows through the primary winding, alternating magnetic flux is produced, which then induces a proportional alternating current in the secondary winding. CT generally consists of only one or very few turns as its primary winding. In contrast, the secondary would have a large number of turns wound on a laminated core of low-loss magnetic material. The ratio of primary current to the secondary current is known as the current transformation ratio of the CT. Usually, the current transformation ratio of the CT is high. Normally, the secondary ratings are of the order 5 ampere, 1 ampere, or 0.1 ampere, whereas the primary ratings vary from 10 ampere to 3000 ampere or more. Of course, there are several advantages about CT. First, easy supply and control functions. A CT is powered by the current it measures. It does not require additional power. Furthermore, the output signal of a CT can directly activate electromechanical relays. It does not need any further amplification. Second, easy maintenance and installation. Damaged CT components are easily replaceable. Current transformers have a high mechanical strength and a compact size. They are simple to transport, store and set up. Apart from that, they are maintenance-free throughout their lifespan. However, CT also has its disadvantages, which is open circuit CT produce extremely high voltage spikes. A CT may become open circuit due to a wiring error during installation or afterwards due to loose crimping, accidental disconnection or sabotage. Open circuit conditions in a CT can cause dangerous voltage spikes at the CT secondary terminals. When a current transformer secondary is disconnected from its load while current is flowing in the primary, the transformer secondary will attempt to drive current over the effectively infinite impedance. For certain current transformers, this voltage may reach several kilovolts and may cause arcing. This voltage is generally enough to maintain a steady state arcing between CT shorting blocks and poses a fire danger. Furthermore, the high voltage generated endangers operator and equipment safety and permanently affects current transformer accuracy. Since the main flux is no longer neutralized by the secondary flux in open operation, smaller current transformers may not really encounter harmful voltages while functioning properly. Faster current transients from loads being turned on, as example, might still cause harmful voltages levels due to the high current load. In conclusion, handling of electrical appliances always needs an expert. As mentioned before, even though CT lowered the current in the secondary winding, it cannot operate in open circuit as a high voltage is there and causes flashover due to the high current source. Therefore, always seek the knowledge from expert and safety first. CT is one of the instrument transformers which help our daily life by using the concept of electric and magnetism as its main component for the CT to be able to function. Thank you for watching. Bye bye.